Well, good afternoon, everyone, and thanks for attending our webinar titled Unleashing Synthetic Data, Fueling Innovation While Safeguarding Confidentiality. We're excited that you're able to attend today. My name's Greg Ingen. I'm the president at Cantata. At Cantata, the focus of our organization is helping organizations solve the challenges and find the opportunities associated with digital transformation. Digital transformation is sometimes an overused term, but a very important concept. Almost every organization is in some level of digital transformation. We can kind of think about digital transformation on like a maturity curve. Some organizations are just at the beginning of it, while others are several iterations and initiatives into it. For us and the work that we do here at Cantata, digital transformation lies at the intersection of data, analytics, and application development, where data is viewed as a strategic asset that needs to be acquired, organized, and cared for over time. Analytics are developed to solve high value, high volume business challenges, then put in at the moment of truth where business can be impacted. And finally, powerful modern applications that are powered by that data and analytics. I also have the privilege of introducing our topic and our presenter. Dhruv Takola is one of our senior data science engineers and will be presenting the topic today around synthetic data. He'll be telling us what synthetic data is, why it's important, and how you might benefit from it. For Cantata, it's a really important concept and tool. As Dhruv will be sharing, synthetic data helps solve several key challenges associated with data, including data privacy and security. At Cantata, being a global company that often works with sensitive client data across multiple teams, synthetic data is one way to help mitigate risk and empower our teams to help develop great digital and analytic solutions. I'd ask if you have any questions, please put them in the chat here, and we'll be addressing those at the end of the presentation. Now I'll pass it over to Dhruv.
All right. Thanks, Greg, for the introduction and kicking things off. So through the course of this webinar, we'll briefly explore the current landscape of data, how we use it today, and what are the common challenges. Then uncover how synthetic data serves as a powerful solution in overcoming those challenges. Move on to taking a look at the present-day industry acceptance, the future, and what's driving the trend for synthetic data. Finally, a quick walkthrough of how we at Cantata have been proactively using synthetic data to address business problems for our clients. Let's get into it. All right, so in today's dynamic and competitive markets, data is our most valuable asset, and harnessing its full potential requires a holistic approach that combines descriptive insights through BI and analytics to understand the what and the why, along with predictive analysis to try forecasting what will happen next, and finally, prescriptive decision-making enabled by AI and ML models to understand how to react. Together, these three enable businesses to make proactive and strategic decisions and gain a competitive edge. But no matter how powerful the data is, almost every project is plagued by one or more of the modern-day data challenges, the top three of which are data privacy, limited data, and data bias. We'll get into each of these in a little more detail over the next few slides. All right. So, highlighted on the left are some personal attributes such as SSN information, biometrics, account numbers, etc., that are considered as sensitive across all domains and need to be protected no matter how we intend to use the data. So, the challenge of data privacy is all about how to protect sensitive data while trying to leverage value from it. The primary driver of data privacy is the high risk associated with sensitive data, and we enforce it via stringent regulations such as GDPR, HIPAA, etc., and contractual terms requiring organizations to maintain data security at rest and in flight. Now, the impact of data privacy is seen across both descriptive and prescriptive use cases in the form of elaborate and long-bounded project negotiations for sharing data, complex setups being required to balance between access and security to ensure that only authorized individuals can use the data, and impediments in the distributed development and deployment process, collaborations, and adding extra resources as required. The second challenge is limited data. And this one can be two-pronged, unavailable data and or unusable data. Now, outlined on the left are the most high impact repercussions of working with limited data seen in business, ranging from reduced efficiency and increased financial cost on account of having to QA the data to missed business opportunities and misanalysis at the point of decision making. The primary drivers of limited data being acquisition cost, both financial and in terms of effort, especially in the case of rare events data. Data fragmentation, making uh, data fragmentation meaning the data is distributed across multiple systems, making it challenging to aggregate and integrate it for holistic analysis. Privacy concerns and contractual terms limiting willingness for sharing valuable data sets, and quality concerns, which is inaccuracies and lack of faith in the source or the collection process, leading to data sets being discarded partially or completely. Moving on to the third challenge, data bias. This refers to skew or bias in the data, leading to poor downstream decisions. The primary drivers for biased data include underrepresentation of minority groups, examples being cancer patients, are a very small subset of the overall population, and homeowners of ethnic origin, right? Other factors could be socioeconomic, which prevent proper representation of certain groups in the overall population. The impact of using biased data is seen across prescriptive and predictive models. Poor performance for certain groups due to lack of appropriate representation in the data causes the models to lack performance. And it also leads to perpetuation of bias because biased data leads to biased decisions, which lead to more biased data in the next collection cycle, forming a loop. So now that we've discussed the dominant challenges, let's look at synthetic data and why it's gaining so much traction out there. As defined by IBM, synthetic data is information that's been generated on a computer to augment or replace real data, to improve AI models, protect sensitive data, and mitigate bias. To unpack it in simpler words, synthetic data is generated by looking at the original data set and creating more like it while retaining statistical patterns. Now, anyone who's worked with sensitive data would have most probably heard of fake data. Synthetic data is similar to fake data, but not exactly. It holds more integrity, meaning it comes out pretty much similar to the original. And it manages to do so on account of certain key characteristics, such as being representative, preserving data quality, class balancing, and ensuring privacy. Next, we'll look into how each of these enables synthetic data to overcome the challenges we previously discussed. Right. So, diving into the first one, being representative. This means that synthetic data closely resembles the original data in terms of statistical properties, including field level properties such as means, attribute distributions, variations, etc., and global properties such as inter-attribute correlations. The benefit of this is that we can build BI and reporting that doesn't look bogus on account of fake data, but rather is reflective of the actual data. And any analysis and insight generation which is done using the synthetic data will also carry over as is to the original data. The next one is preserving data quality. This refers to the fact that the algorithms employed in generating synthetic data strive to closely reflect the quality of the original. This helps capture the nuances in the data. Example, if we have a numerical field in the original data set, which during data collection inputs some text values into it, this will be replicated in the synthetic data to the same degree as in the original. Now, the benefits of this are that ETL workflows built using synthetic data will be more resilient in terms of catching and proactively addressing such issues. And it minimizes the scope of unforeseen errors when integrating into production systems. The next one is class balancing. This refers to offsetting the skew in the data by adding more samples for the underrepresented groups, resulting in equality. The benefits of this are enhanced model performance in terms of higher accuracy for all groups and reduced bias, along with better minority class representation in the data, creating a more balanced data set for all other downstream use cases. The last one is ensuring privacy. This one means that synthetic data guarantees no backward traceability. Individuals or minority groups cannot be traced back based on certain feature combinations. The benefits of this are easier distributed development. Since privacy is not a concern, data can easily move between geographically distributed teams. Easier regulatory compliance, because the data does not hold information about any actual individuals, and minimized risk in the event of a data breach. Even if the data does get leaked, because it does not represent any actual individuals, there's no information loss. All right. Now that we've covered what synthetic data is and how it facilitates various data use cases, I want to take a moment and highlight the different approaches for generating synthetic data. There's a couple of popular ones out there, each with its own nuances and advantages. The first category of techniques is rule-based models. Think of these as a set of if, then, else conditions. And the conditions are based purely on assumptions about the original data's characteristics. The next one is generative models, which falls under the category of machine learning based models. These use a combination of two modules, a generator that is in charge of creating new data, and a discriminator, which is in charge of differentiating between the new and the original. The model keeps training until the generator can outperform the differentiator. The last one is variational models. These are also a class of ML-based models, and they incorporate an encoder, which basically maps the original data into a latent or lower dimensional space using only the most impactful features, and a decoder, which then samples from that space, ensuring that there's no match with the original data. So the next question that begs to be asked is synthetic data already being used anywhere? And the answer is yes, it is being used, and more actively than one would imagine. Highlighted here are some of the most interesting and relevant use cases of synthetic data. In automation and the robotics industry, to simulate scenarios that cannot directly be tested in the real world. In financial services, to improve fraud detection models and to ease data sharing. In healthcare, to solve the class imbalance issues because of rare pathologies, and to create more data for research. And in marketing and human resource, to ease data sharing and facilitate distributed development. All right, so what does the future of synthetic data look like? The graph on the left has been taken from a Gartner report and indicates that by 2030, most of the data used in AI-related applications will be all synthetic. The same report states that it will almost be impossible to build AI models of high quality and high value without using synthetic data, and that the original data will simply act as a seed. The primary factors driving this trend are the realizations that we can generate synthetic data at scale and at low cost, which in turn reduces the time to market and decreases the overall cost of ownership for companies. All right, now that we've discussed the what's what of synthetic data and what the future trend is projected to be, I want to highlight some of the technical challenges involved that drive the need for expertise in this domain. The first one being handling high dimensionality. As data dimensions increase, so does the complexity of the ML models involved, and the computation cost to generate them also scales up. The next one is management of metadata. Accurate mapping of cross-relational dependencies needs to be meticulously implemented and requires a certain expertise. The third one is privacy guarantee. Preserving privacy by analyzing all combinations of attributes that could possibly allow backward tracing requires a certain amount of knowledge. The next one is iterative modeling. The data generation involves iterative refinement, till the output aligns with the use case at hand. And then the last one is addressing randomness. An advanced understanding of the algorithms is required to introduce and regulate randomness in the data for it to match the original. So these are all key factors which require certain expertise and knowledge about the know-how in this domain. All right. So here at Cantata, we have actively been using synthetic data to solve business problems for our clients. The case study showcased here is for a project that we just wrapped up. It was for a large-size staffing company, and the challenge at hand was to build out an elaborate BI system and a talent value model for them. Owing to the sensitivity of the data and all the regulations that they had to comply with, the client could not directly bring on board a bunch of developers. So we stepped in and we leveraged synthetic data to facilitate a distributed development model. There was an on-site team of authorized users with access to the data that worked on the synthetic data generation process. And then there was an offshore team in place that used the synthetic data for the development of the different modules. The outcome and the benefit to the client was reduced cost of development on account of not having to go back and comply with regulations, and the fact that synthetic data could be generated at scale as required. Faster development on account of the team not requiring authorization and different kinds of compliance regulations, and high quality reports that could easily be used as a plug and play into the production system. All right, that was all from my side, and I'll hand it back to Greg now.
Thanks, Drew. Great content. I'll open it up for any additional or any questions that anyone may have. If you can just put those in the chat, I'll address them now. Okay, first question. How do you validate the quality and effectiveness of synthetic data?
Right. So the validation of synthetic data generally involves assessing its similarity to the original, checking the statistical properties, evaluating its performance in specific tasks or applications, and comparing the results against real data benchmarks. There's various validation techniques out there, such as visual inspection, statistical tests, and benchmarking. But most of the techniques do conclude in a side-by-side comparison of across different use cases, pitching the synthetic against the original data set and making sure it is an exact representation of the original. Now, how we do that is a more technical aspect and requires a little more know-how of the algorithms and the ETL processes.
Thanks, Drew. Thanks for that question. Any additional questions? Okay. Well, again, I thank you for your time. In closing, I'd ask if this resonated with you at all, or if you have questions about synthetic data, we urge you to reach out with those additional questions, or if you want to engage. One easy way for us to get a little bit deeper into your situation is to do an assessment. We do data architecture assessments often. What this allows us to do is really understand the uniqueness of a given client situation, and then do an assessment on the appropriateness and how we might apply things like synthetic data, along with cloud migration, building and management of data lakes, as well as AI and analytics application and readiness overall. So again, the assessment is one good way for us to get deeper into your business and start to help solve some of these challenges as well. With that, I thank you for the time, and I'll close it out here. Thanks again for attending.